This is our Summer Math Week 4. Simplify each expression. We'll begin by distributing 6 times both terms in this parentheses. 6 times 1 will be 6. 6 times minus 2 will be a minus 12b. Then distributing minus 2 times both of these terms. Minus 2 times minus 8 will be a plus 16b. Minus 2 times plus 5 will be a minus 10. Next, we will combine our like terms. The constant 6 is like the constant minus 10. 6 minus 10 will be a minus 4. The minus 12b is like the plus 16b. Minus 12 plus 16 will be a plus 4b. Perhaps you wrote it in standard form, that is decreasing powers of our variable. It would be 4b minus 4. Either of these last two are acceptable. Solve the equation. We want to find the value of the variable r that makes this statement true. I could distribute on my right hand side, but I'm going to begin by dividing by -3. What I've noticed is that -3 goes nicely into 120 there, and so that is 40, and it'll make this a little simpler to deal with. If you distributed -3, perfectly okay. Solving for r, I'll add 8 to both sides. Minus 8 and plus 8 sum to 0, leaving 6r. 40 plus 8 is 48. Solving for our variable r, we will divide by the coefficient 6 on both sides. 6 divides 6 to leave r. 48 divides 6, that's 8. You could take this value r equals 8 and substitute it back in for r to verify. I'll leave that for you. Solve for the indicated variable. Here we're solving for x. Well, if I want to get x by itself, I just need to deal with this m. In this case, I will subtract m on both sides. M subtracts m to leave x, our variable of interest. And here I will, none of these are like terms, I will simply leave it as n minus p minus m. We have solved for x. Solve by factoring, number 17. To solve by factoring, we first set the equation equals 0. That's done. Now we're going to factor this left-hand side. Hopefully you see this is a difference of 2 squares. So this is very easy to factor into r plus 7 and r minus 7. This one would be much easier to solve directly by taking the square root, but it's asking us to solve by factoring. Once we factor, we will set each of our factors individually equal to 0. R plus 7 is equal to 0, or r minus 7 is equal to 0. This is our zero product property. Solving for r, we will subtract 7 on both sides here. This leaves r is a -7. Here we will add 7 to both sides. R is a positive 7. These are our two solutions. We could substitute them back in to show. Another way to express this would be that r is an element of the set -7, 7. It's not an ordered pair. It's not an x and a y. A lot of different ways to write this. A wrong way would be as an ordered pair. It's not an x and y. It's two values of the variable r. Solve by completing the square. Well, when completing the square, the first thing we do is collect our constants on one side and our variables on the other. So in this case, I will add 29 to both sides. When I do on the left-hand expression, I have v squared minus 4v. And then on the right side, 3 plus 29 is a 32. Now I'm going to add in my box number. This box number is a special value that's going to allow the left side to be written as a perfect square trinomial. The box is equal to 1/2 of b squared, and this b is in our form ax squared plus bx plus c equals 0, our standard form of a quadratic, b being the coefficient of the linear term, the first power term. of b in parentheses. We take half of b, then we square it. So in our case here, we're taking 1/2 of negative 4, and then we are squaring. So 1/2 of negative 4 is a negative 2. Negative 2 squared is a positive 4. The box value will always be an added amount because we're squaring some quantity. So our box quantity in this case is 4. The box became 4. Alright, now we can factor our left side. The square root of the first term goes first. The square root of the last term goes last. This operator goes in the middle, squared. 32 plus 4 is 36. That's nice. That's a perfect square. Now we can take the square root of both sides. The square root of our squared quantity and the square root of 36. Well, the square root of 36 is both positive and negative 6. The square root of something squared, they just cancel. It's the inverse operation. It's the whole reason we added the box number in. We have v minus 2. Now we have two different statements. V minus 2 is a positive 6, and separately, v minus 2 is negative 6. Adding 2 to both sides here leaves us that v is 8. Adding 2 to both sides here leaves us v is negative 4. These are our two solutions. V is 8 and negative 4. You can substitute that in to see. Factor each completely. Here we have 4 terms. When we have 4 terms, we'll factor by grouping. I'm looking at my first 2 and separately my second 2 terms. Between my first 2 terms, the GCF will be a 4x squared. 4 divides 8 and 12. X squared. When they both have the variable, go to the least power and take it all. So 8x cubed divided 4x squared will be a 2x. 12x squared divided 4x squared will be 3. Now, between 14x and 21, 7 is the GCF. Can't take an x out, they both don't have it. 14x divided by 7 is 2x. Minus 21 divided by 7 is minus 3. Now you'll notice that they have this common binomial factor of 2x minus 3. We can factor that out. 2x minus 3. If you look at this whole first term now, this whole first factor, this whole first expression, 4x squared times 2x minus 3, if we factor out the 2x minus 3, we're left with this 4x squared. On our second one, if we factor out the 2x minus 3, we're left with a 7. Plus 7, I should say. And we could distribute this to see that it is indeed equal to our original statement up there. Factor the common factor out of each expression. Here we're just looking for a common factor. Well, hopefully you can see you cannot factor out an r. They all don't have it. So now I'm left with some constant. What number divides 6, 12, and 12? Well, that would be 6. And in this case, I'm going to factor out a negative 6. Why negative? Well, typically we want our leading power to be a positive. That's helpful when we're factoring, especially when we use our big X method. We have r squared minus 2r plus 2. And this one indeed will not be factorable beyond that. You could, to figure out it's not factorable, you could look at the discriminant and you'll see that it is not a perfect square. Alright. Factor each completely. Here we'll be able to employ our big X method. We have p squared plus 3p minus 70. We'll begin with 2 parentheses. We know to get a p squared we need a p and a p. When we use our big X method, and the bottom is a times c and the top is b. In this case, a times c will be a minus 70, a being 1 and c being minus 70. B will be plus 3, our coefficient of our linear term. We want the paired factors of 70. One of them will be 7 and 10. Since this is a minus, one's a plus, one's a minus. Our sum is a positive. We'll need 10 positives and 7 negatives. These constants will go here. Lastly, we should divide by a, but our a is 1, that won't change anything. We could multiply to check. Evaluate each expression. When we're summing signs that have different, when we're summing numbers that have different signs, we simply subtract the numbers, and the bigger absolute value gets the sign. 4 positives and 1 negative. Since there's more positives, the result is positive. If you have $4 but you owe somebody $1, you really only have $3. Find each product. We will multiply. Product is the result of a multiplication. Distributing my 8v. 8v times 7b will be a 56v squared. 8v times 5 will be a 40v. Minus 5 times 7v will be a minus 35v. Minus 5 times plus 5 will be a minus 25. Notice these two terms are like, often the case when multiplying binomials together. 56v squared. 40v minus 35 will be a 5v minus 25. Alright, here we're multiplying together some radicals, some numbers and some square roots, taking square root of 5 times both of these terms using the distributive property. Consider the number out in front of my radical here to be a 1. It's like a 1 coefficient. Well, 1 times minus 4 is a minus 4. Square root of 5 times square root of 10 is square root of 50. We simply multiply the radicand together, the underneath part. 1 square root of 5 times 2 will be 2 square roots of 5. That makes perfect sense. Connected means multiplied. 2 times the square root of 5 is 2 square roots of 5. Well, this square root of 50 we can rewrite as square root of 25 times the square root of 2. Well, the square root of 25 is 5, so negative 4 times 5 is a negative 20. We have negative 20 square roots of 2 plus 2 square roots of 5. We cannot simplify these any further because the radicand here is different. We cannot sum these. This is the simplest answer. Simplify the expression. When we're adding together polynomials, we can simply drop the parentheses. So I rewrite this without the parentheses. If it were a subtraction in between, we would need to change the signs in the parentheses after the subtraction. Now we're simply combining like terms. X to the 4th is like x to the 4th. Negative 7 minus 2 will be a negative 9 x to the 4th. X squared is like x squared. 6 plus 7 will be a 13x squared. It has to be the same and it stays the same. Technically, we should regroup these or rearrange these using the commutative property. Addition is commutative. We should change these subtractions to plus a negative, but we can simply get to our answer. 4x plus 3x, that's going to be a 7x. Alright, that concludes this video.